like this. Okay. Welcome to my review of the Bluetti AC200. Let's look at this unit and see how well it performs to my tests. Let's do it. Now, unless you've been living under a rock, you'd know that lithium battery packs have been recently replacing traditional electrical generators. Designs keep getting better and better with more capacity and more features, and the AC200 promises to be one of the best in the market. Let's see if it lives up to the hype. Alright, first impressions. It's pretty, but it's big. It weighs 51 pounds and it measures about 17 inches by 12 by 15, 16 by 12 by 17. That's pretty big. This right here is a pre-production prototype unit, and as such it doesn't have, or it didn't come with any documentation at all, right? So what we do have is one label here, and let's go through it and see. This is the model number AC200, battery capacity 1700 watt hours, and it says voltage 51.8 volts, 33.1 amp hours, right? Input PV, that's photovoltaic or solar, 31 to 150 volts DC, 12 amp max. That's pretty cool because it means that you can put a bunch of solar panels in series. And 12 amps, yeah, that's quite a bit of charging. Car charging 12 to 30 volts, which is cool because that means that you can do a single 12 volt battery or double batteries for 24 volts, right? 8.2 amps, adapter 58.8 volts, 500 watt max. 500 watts, okay, that's better than the last version that I reviewed for this company, but it's still quite a bit lacking from the competitors, right? The competition is doing 1200 watts charging. Now you don't need that much, but it's useful sometimes, right? So here we go. Now let's look at the input. AC 100 to 120 volts AC, 60 hertz, 50 hertz, which means that it's compatible with Europe, AC, like American Standard, North American Standard, or European and some other countries around the world. 2000 watts. Okay, so 2000 watts. That is more than the competition. So as far as I know, this is holding right now the record of what's available out there. Oh, actually this is not available yet, but of what's going to hit the market on these type of devices. Available, okay, DC, yeah, what is this? DC 5521, so 12 volt 3 amp times 2. Aviation sockets, 12 volts 25 amps. There we go. So if you want to power something that's 12 volts, it's good up to 25 amps. USB 5 volts 3 amps times 4. Type C PD, so that's 5, 9 volts, 12 volts, 15 volts, 20 volts, right? Which is good because that means it could charge my laptop and all of those high power USB-C devices, which is pretty cool. Cigarette lighter socket, 12 volts, 10 amps. Wireless charging. What? Yes, that is correct. This unit says it has wireless charging output here. Now, which variation of the charging? I don't know. We'll look into that. We'll have to see if it'll be able to charge my iPhone, right? But we don't know yet. So, working temperature 0 to 40 degrees C. That's pretty good. Working humidness 10% to 90% humidity. So okay, so it's pretty well rounded. Those numbers are pretty good. Now let's see if it actually does those numbers. First things first, I'm going to probably have to charge it. So let's charge it. All right, here we go. So I plugged in the provided 500 watt brick. That is connected here. This is kind of weird here. It's probably not gonna be like that on the final version, but it's okay. So it's 49%, right? And right there you see it's charging 400 watts. Let's see if we can charge using multiple, right? So just like also the solar right here, so that way maybe we can speed up the charging. All right, I've installed 3 panels, 100 watts each, right, in series, going into the machine here. And let's see, what does that show? Look at that, it is charging simultaneously 184 watts via solar and 395 watts off of the AC unit. So this is pretty good. Now let's see how much solar we can push. All right, so I've only been able to get about 250 watts on the solar side, even though I'm using 5 solar panels, right? So there's 5 solar panels that I have available, readily available. I think I can do one more because this is only at around 80 volts, loaded up to 3.5 volts. Yeah, the sun is kind of down, but of course remember that the solar charge controller goes all the way to 150 volts, which means that maybe 2 more panels, maybe 2 or 3. So this is 5, 6, 7 panels maybe you could put on there, which is pretty cool, right? Now let's see how much we can get. I'm gonna simulate a solar source, right? And so then we can really see the capacity, the full capacity of this unit. And the way we're gonna do that is by using this thing here. Look, this is what comes with. This is the charger, 500 watt charger. Now this one here is something that I just picked up. It's a 48 volt power supply. This is 1500, capable of 1500 watts, right? So I am going to put it through a DC to DC, and I'm going to variate the volts, right? Hopefully to simulate, find wherever the sweet spot is on the solar charge controller here, and then see if we can hit a theoretical maximum of, what is that? So 12 volts, 12 amps at 150 volts. That's a theoretical maximum of 1800 watts that this guy supposedly can do, right? And if that's the case, man, this thing has the capability of charging really fast using solar. So let's test it. All right, here we go. This is the 1800 watt capable DC to DC, right? I can adjust the voltage and stuff. And right now I have it set up at around 12 amps, 98 volts, right? So let's see if it could push that much power into the unit here. Let's plug it in. Here we go. So it takes a little while for the unit to turn on the relay and connect the solar power in there. Okay, there we go. 96 volts at 5 amps. That's 480. Yeah, so under 500 watts. Is that the same thing that it's saying here? Yeah, pretty much the same. I think it's trying to look for the optimum performance. Let's see if I can mess around with it and find the best results. All right, you see that 711 watts? It seems that is a limit of this unit, because no matter what I do, now I have 2 separate power supplies, right? A 200 watt here and an 1800 watt here. I thought maybe one of these was going to be the problem, but now I have 2 of these units pushing power. This meter here says 800 watts going into the unit, right? This is measuring the cables that is going right up to this unit, but this thing here is only reading 700. So as it turns out, that might be the limit here. Now the good thing is that you can simultaneously charge both. So let me connect the AC power on this one also. Let's see. I might trip that breaker over there. Huh. Okay, now I have connected both. And 700 watts of solar and the DC. Why is it only says 5 watts? Okay, there we go. 400 watts. Woo, okay, so that's 1100, almost 1200 watts. Yeah, okay. So you could charge this unit at a rate of 700 watts. It's just you'll have to do a bunch of things like connect it straight to the wall and connect 700 watts of solar panels in there, right? But I mean, at the very least, you can do it. It's possible, right? It's just not as easy as the competition where it could just plug it into the wall. It'll charge at 1200 watts. I'm gonna skip all the nonsense appliances and just go straight to the biggest one that I can find. That's right, my Tesla. So I have plugged in the Tesla. It's charging. This thing says it's putting in 1300 watts. This thing also says it's putting 1300. So we'll see how much energy this little thing can store there. And I will test to see that we can hit the 2000 watts in here. And hopefully we can hit close to 1.7 kilowatt hours here, right? So let's go look inside the Tesla to see what it's saying there. Okay, here we are inside the Tesla, and yeah, it's putting the max amount of current that you can do at 120 volts. So 12 amps, that's 1300 watts, right? 12 out of 12. It's saying it's gonna take 9 hours and 50 minutes to charge that much of power. So, you know, not a whole lot of power that this car needs. It's almost fully charged all the way, but yeah, 9 hours according to this. Also, let's see, can we move this thing here? Yeah, we're gonna do a trip tomorrow, so let's set it so that it can charge the entire range of the battery here. There we go. Alright, let's push this guy to the limit. Now, aside from having the Tesla charging right now, by the way, it's taken out about 20% of the battery already. Now I have a secondary load in this guy right here, which is a heater. This one will do 500, 1000, and 1500 watts. So I'm gonna turn it on right now. It says 1366. 1366. Let's turn on the 500. Oh, it didn't like that. 500. What is 500 and 1300? Well, that's under 2000 watts. It should have worked. Let's see. Maybe it needs to ramp up slower. So now I put the car in there. Right, and hopefully the car is gonna start ramping up. Let's see. 500, 1000, 1700, 1800. There we go. That's what it was. I guess it can't get there too fast because then it trips it. So this 2000 watt that it's there, that's like the max. Maybe that's like the peak, and if it reaches that, then it trips the breaker. But there we go. 1850, 1860 watts right now. All right, now let's check to see if it will charge my phone. No? Oh, there we go. Look at that. See? I don't know why it's fiddly, why it doesn't charge always. It's just but it seems like it's charging right now. There we go. All right, you see the little thing there? It's charging. Nice. Next test is going to be the sine wave. Here we go. Under load. Under load. Here we go. It looks pretty clean. It looks pretty sine. Yeah, this is while it's loaded with 1400 watts. So there we go. It's pretty good. All right, next test is the DC output port over here, the 12 volt 35 amp. I want to test to see and make sure this one does give us 25 amps. That's about 300 watts. So in order to test that, I am going to go through this guy so that we can see. And here you go. Here's the voltage, 13.4 volts, which is good because that is essentially what 12 volts automotive is. It's not really 12 volts. It's more 13.3 volts. Okay, so then it's going to go through this inverter. This is our load, and it's going to be a bunch of lights, right? So let's see if we can get 300 watts off of that thing right there. Turn on the inverter. Boom, there we go. So that's 13 amps. 20 amps. Look at that. There we go, 25. There we go, it gives us 25. Two of the lights just happen to be the exact load that we need. 25.9, 26. Yeah, it's right there. It's holding. So there you go. That DC port does provide you 25 amps. There we go. All right, so the result is finally in. How much did we get out of this battery? 1.3 kilowatt hours. So that means there's like about a half a kilowatt that stayed in there due to inefficiencies. That's pretty inefficient. That's pretty inefficient, I have to say. But of course, this is a big load, right? About as big as it gets with the Tesla. I guess maybe if you go to lighter loads, maybe you'll be able to get better efficiency and get more out of this battery pack. I don't know, right? So next, let's take a look at what's inside. All right, now that we know what this thing can do, let's see what's inside. Let's see the components, how it's built, how it's put together. Let's take it apart. All right, here we go. The top is off, and now for the first time we get a chance to see in there. Look at that. There's a lot of space, empty space on top here, but yeah, I like this design. They do have this one big tunnel that goes through here for cooling with two fans. One fan sucking air in and another one pushing it right out of this thing. And as I ran the test, one full discharge cycle, this thing ran pretty good and it was pretty quiet. These fans were on and I could feel the hot air being removed from this side, but it wasn't, you know, obnoxiously loud, and it didn't feel like it was struggling. So that's a pretty good design when it comes to this cooling, the airflow on this thing is pretty cool. And that right there is the battery. Yeah, it seems to be pouch cells. Okay, so 48 volts right now, and this is a completely empty battery. It's at 0% state charge. So then let's check. Let's see if we can see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is a 14S battery pack. They're pouch cells. And here you can see all of the balance leads that go all the way down here, and then it goes into this massive BMS system. Look at all these MOSFETs. Look at that. And the crazy thing is that even though, well, maybe, no, there's no airflow down here to cool the battery. Maybe it doesn't need it because it's got this heat sink, and maybe it's got enough of these MOSFETs there to be able to handle you know, a full discharge cycle at whatever the maximum speed that this will do. This is obviously supposed to be able to do 2000 watts, but of course you saw on a test that it was, you know, it struggled at anything above 2000 watts, right? So it's like 2000 peak, and it was able to pretty good do like 1800 watts, which is a lot. It's very comparable to all the competition out there, right? So yeah, there's still more room where they can put a bigger battery, but of course the problem with putting more battery is that this is already extremely heavy, and so what ends up happening is that then you're gonna have a unit that is not gonna be very portable. Another thing to notice is that the power button, this is a power button, it goes into this cable here, and then this cable goes straight onto the BMS. So essentially when you're turning on the unit, then you're turning on the BMS system, and then the battery turns on, and then the power, this gets turned on, right? And then the power goes into all the circuitry for this inverter. So yeah, that's a pretty common thing that I'm seeing with all of these units, and I think that is a pretty smart thing to do, just to turn the battery off when you want the system to be off, right? Other things to note here, I mean, it's just a pretty cool design. Look at all these extra solder in there, basically to be able to increase the capacity of this circuit board here. Let's do the math here. So at 2000 amp or at 2000 watts, this BMS here has to be able to handle about 40 amps, right? And so that's why these are, you know, big cables in here. These are what, 8 American wire gauge cables. They're silicon cables. These are pretty good stuff. Yeah, and a big beefy BMS. I don't know what this is. There's like a big giant resistor here. Why would there be a giant resistor? What is it? 50 watts. Okay, something to notice here is that the PV is included, it's integrated into the main board there. So if you ever had a problem with that unit, you couldn't just replace it. You'd have to replace the entire board. And it seems like obviously this is a custom board. It's pretty good, but I wish it was separated so that you can you know, service it. So yeah, the technology seems pretty good. This battery seems pretty good. I mean, it's almost like EV status right here, EV module size, and you know, they're probably, these are cells that are found on EVs because they're that big, right? But as far as the inverter, seems like it's a custom size inverter. Seems well designed. I think it's gonna be fine. It's just the whole integrated into a single board is a thing that is not the greatest in the world, because it's not going to be so serviceable. As far as the casing goes, yes, plastic. I mean, unless they do some crazy, you know, like fiber and carbon fiber, you know, embedded some kind of material. I think if you were to drop this one, it's gonna break and it's gonna fall apart, because it's one big giant, you know, single piece of plastic that is just holding everything, right? So yeah, this is definitely gonna crack and it's gonna break. I really wish they would have done some kind of aluminum frame around this box inside, and maybe they are going to do it. There's space for it. Definitely there is space to do it, but I don't know. I mean, this is pretty far along. I think this is going to launch in a couple of days, so this could be a very early version of prototype, but it could also be really late, and this is really what it's going to look like. It's just the material's going to change, and that, right? But that's just physical stuff. Aside of the electronics, they seem pretty good. They perform like the specs say. It's a bit inefficient because obviously we were only able to get 1.3 kilowatt hours. So that means half a kilowatt stayed in the inefficiencies here, right? And so that's not the greatest, but I think it's to be expected, right? So, all right, let's put this back together and then see if, see if we can make it work again. So there you go, the AC200 by Bluetti. Overall, pretty impressive unit with lots of features, decent power output, and good looks. There are still some things that I would improve, like adding, for example, more surge power. This pre-production unit I receive only does 2000 watts, which means it will have trouble starting big appliances like AC units and some power tools. Supposedly, the production unit will double this power to 4800 watts of surge, so we will have to see. I would also add more reinforcement to the body of this unit, like an aluminum subframe, so it can withstand shock better, as housing 50 pounds of batteries in a plastic box is just asking for trouble. Also, the information screen is a bit hard to see in the sun, so I'm hoping that the production unit will have a better one. Now let's talk about price. How much will this set you back? I'm told the AC200 will eventually retail for $1,800, but the manufacturer has launched a Kickstarter campaign and is offering lots of early bird discounts. Like, for example, the first 200 people will be able to get the unit for only $999, while a second tier will pay $1,199. That campaign launches today, and if you're watching this early enough and click on the link in the description of this video, then you can really save lots by buying early. I hope you enjoyed this review of this pre-production unit, and I hope that you come back another time to watch another one of my videos. Thank you for watching. Until next time, bye.